Hi, everyone. Thank you for joining us today. My name is Sawmill, and I'm joined by my colleague, Dr. Gabriella Melki. We are both lead data scientists working on Modzi, which is an enterprise AI platform and model marketplace. We built Modzi because making AI work in the real world is pretty difficult. And one of the main reasons why is once a model is deployed into production, there are a lot of different scenarios that are difficult to anticipate and prepare for that the model may encounter. As much as we as data scientists try to employ techniques during model development that'll make your model generalize better, there are just some things that are going to occur that are difficult to account for beforehand. And even getting to that point where the model is deployed into production is pretty difficult in itself. And one of the main reasons why is that before Modzi, there was really no easy way for data scientists to be able to hand off their models to the software developers. Data scientists typically lack the experience to be able to build scalable software applications, whereas the software developers typically lack the machine learning expertise to be able to develop the models in the first place. And so the result of this is Gartner actually in 2019 estimated that 47% of models never actually make it out of the lab and into production. And those that do actually take 9 months to get from the lab into production. And so although this process is pretty difficult, we spent a lot of time at Modzi trying to think of ways to make it a lot easier. And today we're going to kind of zoom in on a couple of key areas, specifically automated model deployment, as well as model retraining when that is deemed necessary. And we'll talk a little bit more in detail about that and show you some cool demos. But if you would like to kind of learn more about a few different areas that we found crucial to this process and making this whole thing work, specifically around model drift, adversarial attacks, and explainability, I highly encourage you to attend our other talk, one of our other talks at GTC, which is entitled 3 Reasons Why Your AI Will Fail: Model Drift, Adversarial Attacks, and Lack of Explainability. Okay, so where does Modzi fit into the MLOps pipeline? Well, it really comes in the model deployment, production inference, and production monitoring and retraining phases. But what about everything before that? Well, one of the great things about the way that we've built Modzi is that we are well aware that data scientists have a lot of popular open source tools and frameworks that they might want to use during the model development process. And we don't restrict you really in any way. You're open to use whatever you want to use. And today we're actually going to leverage a couple of open source tools, one being MLflow and the other being TensorFlow, to be able to develop a model or a couple of versions of a model actually, and track experiments and parameters and metrics throughout the process. But really the point that I want to drive home here is you can use whatever you want. Really the only requirement is that you're able to containerize it according to Modzi's specification. And we provide extensive documentation and actually a lot of template code that makes this process pretty easy for you to do. One more point that I want to make before we jump into some of the demos is that you also have flexibility in terms of where you're deploying your instance of Modzi, whether it's public or private cloud, whether it's AWS, Google Cloud, Azure, or if it's your on-prem environment or in a secure on-prem environment. You can deploy Modzi really anywhere that you could spin up a Kubernetes cluster. So you have flexibility in that way as well. So now we are going to jump into the first of our 2 demos here. I'm going to kind of walk you through an automated model deployment pipeline that we've developed that really takes that Gartner estimated 9 months to go from model development into production down to something that could potentially run in a matter of minutes. So without further ado, I'm going to go ahead and share my screen. Okay, so before we start running things and kind of walking through this demo, I want to explain to you what exactly it is that you're seeing here on the screen. So at the top is a Jupyter notebook that is actually running on a Docker container within an EC2 instance that we have spun up. And that's what you're seeing at the bottom of the screen here in the terminal. So we've spun up an AWS EC2 instance. It's a P3 2x large, which comes equipped with a NVIDIA Tesla V100 GPU. And this instance has access to an AWS deployment of Modzi. And so on this EC2 instance, as I mentioned, we have a container running where we're going to kick off all of these components of our model deployment, our automated model deployment demo that we've developed. And for the purposes of this demo, we've kind of broken this down into 3 main components. The first will be training the model, training a couple of versions of the model, and using MLflow to track hyperparameters and metrics resulting from those hyperparameters throughout the training process, and we'll use the MLflow UI to visualize that. So once model training is completed, we are going to choose the best performing model and use what we're calling our model converter to be able to as I mentioned previously, containerize this model according to Modsy specifications. And finally, we're going to import a little bit of metadata that Modsy needs to be able to run the model. And at that point, we'll have a production-ready version of this new model deployed to Modsy. So I've just kicked off the first step of this process, which is going to be the model training and experiments portion. As I mentioned, we're going to be using MLflow, specifically the MLflow tracking API, to be able to log hyperparameters and resulting metrics for a couple different, specifically 2 different versions of this model. And we're going to see which model performs better and use that model throughout the rest of this automated pipeline. So what you're seeing here is we're basically going to train a couple versions of a simple image classifier. It's not going to be a very useful model. That's not the purpose of this exercise. But really what it is we've taken a few classes from the ImageNet dataset, images of tanks and images of warplanes, and we're just going to train a simple 2-class classifier that's going to be able to differentiate between images of those 2. And we've chosen a couple different sets of hyperparameters. We're going to train in a sequential fashion, although you could do this in parallel and monitor progress while training is occurring. So let's go ahead and take a look at the MLflow UI. We are currently logging our target metric of basically just validation accuracy, but you can log whatever it is that you want specific to your task, whether, for object detection, if it's mean average precision, or if you want to log loss, you can do that as well. So here you're seeing the MLflow UI, which is also running within our Docker container. And this main page corresponds with one experiment. And in MLflow terminology, one experiment consists of several runs. In our case, it's going to be 2 runs, and one run is a complete training of a model with a particular set of hyperparameters. So here you're seeing one of those runs because we are running these trainings sequentially, not in parallel. Once this is completed, another one will pop up. But the great thing about MLflow is that in an organized fashion, you're able to see the input hyperparameters and the resulting metrics. And as training is occurring, you're able to actually go in and monitor the progress in this nice graph of your target metric over time. So let's go back to our main page here. And these green checks mean that training was completed. We had a pretty tiny data set and we didn't train for that many epochs for the purposes of this demo. But here are our final metrics, our validation accuracies. And so what we can see here is that one of the models performed significantly better than the other. Actually, we got 96% accuracy here. So we're going to go ahead and use that one. So we go back to our Jupyter notebook here. Again, we're going to go to the second component now, which we're calling the model converter. So what's going to happen, let me go ahead and kick this off and I'll talk you through what's going on here. We are going to go back to the MLflow logged metrics, choose the model that performed better and pull the corresponding model weight. Then we're going to go ahead and take those model weights and put them into a particular directory within a repository that we've put together that's ready to accept those model weights. And this will result in a Modsy compatible, Modsy deployable model container. As I mentioned, really the only requirement that we have is that you are able to containerize your model, and what that, according to Modsy specifications, and what that entails is really implementing 3 main API endpoints. And we provide extensive documentation and even some template code in which a lot of that is actually implemented for you. So it'll be super easy for you to be able to integrate your trained model into that code. So that's what we've done here. We've taken the best performing model weights, placed them into the container repository that we've put together. And we've also automated the process of building the resulting Docker image and pushing that to AWS ECR, Elastic Container Registry. And so this message at the bottom is an indication that this whole process was successful. And we now have a new Modsy deployable model Docker container image inside ECR. So now we're ready to go through that last step, which we're calling the model importer, to actually get the model into Modsy. So let's go ahead and kick that off. What's happening here is that the user is required to fill out a little bit of information inside a YAML file. These are things like timeout values, specifications of hardware resources that this model requires in order to be able to run, as well as optionally some technical details that will be displayed in the model details page that you're going to see in a little bit here within the Modsy model marketplace. That'll really help other data scientists, other users of your instance of Modsy, be able to understand what the model does and how well it performs. But again, that's optional, and we'll see an example of that in a second here. So this 200 response means that process was successful as well. And so now we've got a new production, inference ready, deployed model into Modsy. So let's go ahead and take a look at what I mentioned a little bit earlier, the model marketplace. What is that? So here's the Modsy model marketplace. Here we have available to you a wide range of pre-trained AI models, many of which the Modsy data science team has contributed. But also we've brought in a lot of top capabilities from leading AI organizations. And so if your organization has developed models that you would like to then monetize via our Modsy model marketplace, please feel free to reach out to us. We'd love to start those conversations. Finally, we do have some models from the open source community here that are free for use. So let's go into one of the model details pages. So for each of these models that we have available via the model marketplace, we have a model details page. And so it's kind of up to the organization. So in your instance of Modsy, it's up to you to set whatever policy you want in terms of what information you want your data scientists to be including for models that they're contributing on this page. But for the models that come pre-trained and ready to go with the product itself, we require a couple of different things. And so we've really tried to emphasize transparency. We want decision makers going through these pages to be able to get as much information as they can and make a decision on whether or not this is going to fit their use case. So at the top is kind of a brief overview of the model's functionality. We'll go to this demo page in a second. If you scroll down a little bit further, we provide some performance metrics. So, just on the left is a description of how well the model performs in certain situations, maybe some situations where we've seen it struggle, as well as a description of what kind of validation data set was used to generate these metrics. And then we have these concrete values here so that you can get a sense of how well the model is performing. If you scroll down a little bit further, in the technical details section, this is where we really like to provide information that anyone, but particularly data scientists, will be interested in when they're kind of taking a look at this page. So things like, what architecture was used and why, what pre-processing was done, what was the model trained on, all those sorts of things are here for you. And finally, if you scroll down a little bit further, we have a sample API request and API response so that developers who want to use this model can easily see how they need to structure their input, as well as get some information on how to easily parse the output, the inference results output of this model. So at the top, if you go ahead and click that, see the model in action, it brings this page up. And for a lot of the models that we've contributed, we like to provide some sample inputs and outputs so that users who are considering using this model can see what it actually does and see the model in action. So here you're seeing our object tracking model track this vehicle as it's traveling down a highway, and it seems to be doing a pretty good job. So the model that we just deployed, here's the model detail page for it. This is a real model. It's now in Modsy and it's ready for scalable and secure inference in a production capacity. And so I wanted to kind of show you how to actually use this model. So for this example, we're going to use the Modsy Python SDK. We do provide a couple SDKs in other languages, Java, JavaScript, and Python currently. This does not preclude you from submitting jobs from other places. You can really submit jobs to Modsy from anywhere that you can submit an HTTP request. But here we're going to use our Python SDK. We're going to import it at the top. Here we're going to scroll down a little bit, and we've written this helper function. So this is where really all the magic is happening. And what I want you to focus on here is the fact that there's only 3 lines doing all the work here. So we're going to submit our file from our local file system, submit the job. We're going to wait until that job completes. And then once it's complete, we're going to pull and return the inference results. Scroll down a little bit further. We're just going to initialize our Modsy API client. Your installation of Modsy within your network will have a particular API endpoint. You'll point to that here. Here you'll specify your API key. When a model is deployed to Modsy, it is assigned a particular model identifier, and you're able to specify a version number. So you'll input those fields here as strings. And now we're ready to submit a job. That's really all it takes. So we're just going to visualize. This is an image that I have sitting on my laptop. So here I've just visualized it, and we're going to submit this image to this model and see what the results look like. So all we need to do is point to that file path corresponding with this image, and we'll use our helper function to do the rest. So once that job is complete, you can see we'll print the maximum prediction, and we can see that this image was correctly identified as a tank. So again, not a super useful model. That's really not the purpose of this. The point that we really want to drive home is that we were pretty quickly able to train a couple of versions of a model run our experiments, track them, visualize using ML flow, and go all the way in an automated fashion to having an inference-ready model in your instance of Modsy. And we did that pretty quickly. So a couple more things that I wanted to point out, some awesome features and functionalities that we provide in Modsy before I hand this over to Gabby, are AI management tools. So we provide AI management tools that really give you a lot of control from a couple different perspectives. The first being security. So from a security perspective, let's first take a look at our API keys page. So you've probably used API keys in a few different places. This isn't a new concept. The way that we kind of break it down is personal API keys. So you might want to use these sorts of things for research and development or experimentation purposes. Maybe there's a model on Modsy, you just want to run a couple of sample jobs to see how it performs on your data. That's the sort of thing you might want to use a personal API key for, and every user of Modsy has one of those. If you're deploying a production application that needs to leverage Modsy models, you'll want to use what's called a system API key in Modsy, which really has a pretty limited set of capabilities on the platform. Really, it can only do what it needs to do to be able to submit jobs and retrieve results. So it's secure in that sense. But as an administrator, I can go in and on a per user basis, control what entitlements they have, which are really different sorts of granular abilities on the Modsy platform. These are things like can submit job, can view job history, can create user. If I want some folks to be able to do certain things, other folks not to be able to do those things, I have that level of control as an administrator. So the next thing that I want to point out is job history. So we have pretty extensive job history logs here. If I need to go back for any reason to see who's been doing what on the platform, what jobs were submitted, when, by who, what models, I can go back to the job history page at any time and I can see all the jobs that have been submitted and processed. And if I actually go ahead and click on one of these particular jobs and go to the details page here, there's some more information up top, but what's most interesting and what I wanted to point out here is that you can actually see the input and output file for this particular job. So all that information is here for you, and for auditing or compliance or monitoring purposes, this is a super useful feature. And the last thing that I wanted to show you is the models page within the AI management tool suite. So here is where on a per model basis, you're able to kind of allocate hardware resources within your environment to particular models based on their different requirements. So we have this kind of concept called processing engines. Processing engines are a layer of abstraction above the actual hardware resources within your environment. And so you can see the value on the left is the minimum processing engine's value and the right is the max. And again, on a per model basis, let's say I have a model that is rarely used and I'm okay with a little bit of time on the front end when a job comes in for spinning up that model, and I'm okay with a little bit of latency for it to be able to process that job, I can keep the minimum at 0. But let's say I have other models that need to be ready and spun up at all times and ready to accept jobs and process them quickly. I would then need to increase the processing engines to 1 or 2. And if I needed to scale, I have a bunch of jobs coming in, high throughput, I can increase the maximum value for that model as well. And once you've done that and you've set these models according to the specific requirements of different models, Modsy is going to go ahead and handle the rest on the back end for you in terms of spinning up models and scaling models. You don't need to worry about any of that stuff as a user. So that's really all I wanted to go over before I hand it over to Gabby, but I did want to recap. We were able to kind of go through the entire process of training a couple versions of a model and getting it all the way through to having a deployed model inside Modsy ready for production inference in just a matter of minutes. Now, admittedly, this is a toy use case. Things in the real world are not going to be that simple. You're not going to be able to do this in a few minutes. We realize that. But the point that I really wanted to drive home is that we have drastically reduced the time that it takes to go from developing a model to having it production ready, from that original Gartner estimate of about 9 months down to something that can realistically be done in a matter of hours. So with that, I'm going to turn it over to Gabby to talk about our retraining system.
Thanks, Sawmill. Hi, everyone. So now that Sawmill talked about our Modsy's model deployment feature, I'm going to take you through an example about Model's newest feature, which is the model retraining feature. And in this demo, we're going to see how this model retraining algorithm kind of gives users this power to train our models on and tailor them to your own data sets. You might think this might not be such a difficult task, but training machine learning models that are generalizable and accurate in production time, usually they need to be trained on large labeled data sets to be able to be trusted with their predictions. And obtaining these large data sets is very, very expensive in terms of time, in terms of resources, in terms of data cleansing and maintenance. It's a huge headache, and I'm sure everyone watching feels the same. And so, and not only that, to be able to train these models on this large data, it's time consuming. And imagine every different task that you might use an AI model for with that much data, how much time you would be spending training. So it's just an expensive task. Model's retraining feature, however, leverages something called transfer learning and domain adaptation to sort of reduce this training time and reduce even the amount of data needed to have a model that generalizes well in practice. So it sort of alleviates the two biggest issues concerned with training a new model for a new task. And so let's sort of get into a little bit what transfer learning and domain adaptation mean. For transfer learning, it's sort of the idea of transferring existing knowledge to help learn a slightly different task. I like to think of the example, like if you know how to play the guitar, you probably won't have a lot of difficulty picking up the bass. So that's sort of the idea of transfer learning. And Monty leverages this sort of idea to help train models on new but similar data to perform new tasks. And so yeah, that's basically the main core of this. It's a little bit more complex in terms of algorithmic stance, but that's the main core concept. It's something that you've already learned, aka like our models on the marketplace. You can take our already trained models and then adapt the model to your specific tailored data sets and needs. So let's walk through this example. In this example, we're going to focus on object detection, and what we've basically done is developed this retraining feature for the YOLO v3 architecture. And we decided to use that because of YOLO's first scalability in terms of time. It's very fast and simple architecture, but at the same time, it retains its power in terms of performance and accuracy. So I'm just going to run this real quick, and we'll get into the example data set that we're going to be working with. So for this example, we're going to use something called the SpaceNet dataset. And this is a dataset that's been curated by CosmicWorks, Radiant Solutions, and NVIDIA. And it basically consists of images, overhead images of different locations taken around the world, basically, for the task, in this case, for building extraction. So the two subsets that we're going to be using are the Vegas subset and Khartoum subset. The training size for Vegas is 23 gigs, testing size is 8 gigs, image count is around 3,000, and the number of labels or the number of buildings that exist are around 150,000. And Khartoum is right below there. what we're gonna start with, we're gonna walk through an example where we're gonna say we have an existing model that has been trained using the Vegas set. And now, you know, after some time, we're using the Vegas, the model trained on Vegas data set, everything is fine. But now we got new data, basically. We were able to gather new data from this cartoon set, for example. And we want to see what the best way to update our model to be able to work for both of these different terrains. So let's start with our existing model that we've already trained on the Vegas data set. As I've said previously, we're going to work with the YOLO v3 architecture. And we've trained it on the Vegas set, and this is sort of our data split where we have 65% for training, 35% for testing. And we've trained it, let's say, for 90 epochs with a batch size of 8, and it uses a GPU, a single GPU. These are the main results of this model that was trained on the Vegas dataset. So we can see that it performs pretty well. And so now what do? We get this new cartoon data set. What's the next step? We could do nothing. We could just, I mean, it's overhead buildings. One would assume maybe it should be fairly transferable, like the model should be fine because buildings kind of look the same from that angle. We could build a new model from scratch. We could build a new model from scratch using that new cartoon data set, or we could use ModZ's novel retraining solution. So first, let's explore the idea of doing nothing. So what I did here was we tested the existing model that's been trained on Vegas on the cartoon data set. And as we can see, it falls flat. This is not usable in production, not at all. So let's take a look at why this is the case. And what we have here is an example of why nothing is not something worth doing, where we have some examples of the Vegas, sample images from the Vegas dataset and sample images from the cartoon dataset. And as you can see, the terrains are way different. The distances taken from the ground are different. The colors are different. All of these things factor into model performance. So, you know, and in this case, it's the same sort of task where we're doing building detection, but imagine if the task slightly changes or a new class is added, things get really complicated. So you can't really use the same model before. It has to be updated in some way. For brevity's sake, we're going to just jump to ModelOps' retraining solution because I can't wait anymore. I'm just kidding. So what does this retraining solution consist of? It's an algorithm that's been tailored, and through like lots of experimenting, we found an appropriate set of hyperparameters. We found specific configurations to tune without sacrificing model performance, while reducing the amount of data needed to perform up to standard, as well as producing generalizable model. And on top of all of that, it's super simple to use, which is great. So the first thing we're going to do is load the weights and load our model like retraining wrapper for YOLO v3. This is this Vegas 90 weights. This is just a path that's pointing to the model checkpoints of the model that has been trained on the Vegas data set. So we're going to load that in with our retraining wrapper. And so this is just some logging information. What it also does is it will take the cartoon data set. It's been pre-trained on Vegas, and we're going to now retrain on cartoon with a data split of 60% for training, 20% for validation, 20% for testing. So yeah, this is basically just loading the wrapper to start the retraining process. And without further ado, this is the retraining code. It's just one line. YOLO v3 wrapper tune model. Very beautiful. So in this case, what we found is we're going to, as we said before, actually, let me take a step back. The model that's been trained on Vegas was trained as I mentioned before, for 90 epochs. In this case, for retraining on Vegas, we're only going to use 30 epochs. And we'll see even that the training and validation loss sort of plateaus or converges fast, relatively fast before we even hit the 30 epoch mark. And we'll see that in a little bit. But yeah, this is basically it. This is going to take the weights that have been, weights of the model that has been trained on Vegas and update it to now work on both Vegas and the newly acquired cartoon data set. This is one of the biggest benefits that you would have for retraining rather than training from scratch on the new data, because you eventually, by training from scratch, you lose everything that you've learned before, and that's not, in most cases, that's not what you would want to do. You would want to update your model. So that's one of the biggest sort of benefits that retraining has. So now let's take a look at some comparisons for 3 different cases. We're going to first take a look at, we're going to compare obviously the ModelOps retraining results with 2 different things. One that's starting from scratch, so training a new model on the cartoon data set. And then, I'm sorry, I misspoke. What we're going to be comparing is first ModelOps retraining results, and then one example where the model we have where we did nothing. So we're using the same model that was trained on Vegas on the new one, just to show the severity and the differences. And then we're also going to take a look at the results for fine-tuning the entire model, rather than using ModelOps retraining solution, which only does select layers, which through experimentation, rigorous experimentation, have been found to boost performance while minimizing the amount of time needed. So as we can see here, we have this original model, our fine-tuned model, and then ModelOps retraining solution. So as we can see, obviously the model from the original one tested on the newly acquired cartoon data set does not, it's not productionizable, it's not even usable. But if we compare fine-tuning the entire model with ModelOps retraining solution, we still see that ModelOps solution sort of outperforms or performs comparably with fine-tuning the entire one, while being faster in training. And in this case, the cartoon data set is not super large, but imagine rather than 1,000 images in total, you had 1 million. So this sort of scalability will help in situations where newly acquired data is super large, because you won't need to use all of it. Now let's just take a look at some bar plots, just to emphasize how ModelOps retraining solution is still amazing. So here we have the validation loss and the mean validation loss, and then mean average precision, the time taken for the validation phase, and precision and recall. And as we can see, ModelOps is still outperforms the original model. Now let's look at, I know I mentioned this before, but I wanted to show you again the train loss, how how fast it would converge. And so this is sort of an example of the loss over time. So like even 30 epochs might, again, the data set is small, but 30 epochs in this case is not super needed. So, so that even reemphasizes the fact that you don't need that many steps to update the model. It's already like at a point where it's generalizable. And here you can see just during training and validation, you can see the results for loss, precision and average precision, recall and F1 over time, like per epoch. And ModZ is always the winner. Some other supported architectures that ModZ supports for retraining. So as we said, we have the YOLO v3 architecture for object detection. We have our CNM family of architectures. For image classification, we have ResNet, and we have a transformer-based language model as well. All of these different types of architectures now support this new retraining feature, which is very exciting. Now, let's circle back around and wrap this up with a bow. So why ModZ? The ModZ marketplace has a ton of different types of models for different applications that have all been rigorously trained. They've been put through the ringer. So they've been trained on massive data sets, they're trusted, and they're available for use. So those can act as your base for, and along with this retraining feature, to adapt these models to your particular domain, which is very like pragmatic. Not only that, as Samuel had mentioned before in the first half of this talk, the ease of model management and deployment, it reduces like the amount of time taken to productionize your AI models significantly. And that on its own is just a benefit. It's something that's not out there, and it's very valuable. So along with those two things coupled together just sort of makes retraining or using this platform easier for your particular domains. It's easily transferable. And finally, security. So everything is trusted. Like you can be sure that our data sets are massive, they're validated, so they're vetted, and our models are tested and validated thoroughly. So ModZ's base models are something to use, and you can leverage all of that. And then finally, some links. To learn more, visit modz.com. And there are a couple of links. There's ModZ Labs subdomain and some blog posts about all of the new things that we're researching, and a little bit more about retraining as well. So you can find those at modz.com/modz-labs, and follow us on Twitter at @getmodz. And thank you guys for listening. Please reach out to us. Love to chat. Thanks again.